So let's look at this question together. A car moves at a constant velocity of 30 meters per second and has 3.6 of kinetic energy. The car stops in 95 meters. So your problem, calculate the force. Your problem here is, which blooming equation am I using? Okay. And so that's difficult enough. So let's start off. Sorry, as I was saying, I can put these on YouTube. You can study them later on, or even in year 11 if you don't understand it all today. So I'm going to tell you something for nothing, that the two equations we're going to use for this question are energy K equals 0.5 mv squared. And the other one we are going to use equals work equals F times distance, force times distance. Okay, now what I'm trying to get you to understand about energy is, and something I wanted to point out to you, that work equals force times distance is nearly the same equation as gravitational energy equals mg h, m times g, because this is, m is mass times gravity times height. Okay, and height is a distance. Okay, and mass times gravity is always the force that you exert as you go around this earth. You exert a force that is related to your mass and is related to the gravity that's pulling on you. Okay, and so what that tells us is, the only difference is, with this equation, we would say in physics, if there's no we say energy is the ability to move a force through a distance. If an object is not moving through a distance, you would say, well, no work has been done. If you multiply anything by 0, you get 0. So no work has been done if the object is not moving. Okay. Well, all that means is no energy is being expended. Instead, energy is likely to be being stored. So there is energy there. So with this one, something doesn't have to be moving to get a result. In this one, if the distance the object's moved is 0, we end up with a value of 0 energy, no work being done. But this one, the object could be just stationary, but it has a height above 0. It's not on the floor. And in that sense, the object is stationary, but it's high up. It has stored energy. And so we can still create a figure. So why have I told you all that? Because it says here, the first one is force. So it means for the first question, this is the equation we need to do. But then you'll say, hold on, sir. We know the distance. Here it is, 95 meters. We're trying to work out the force, but you haven't told us the work. Okay? So it's confusing. So that would make the question almost impossible for you to answer. But then we realize that the kinetic energy can actually be equal to the work. Okay? And that's what I was trying to say here. Energy, mass times gravity times height, okay, is practically the same equation as work equals force times distance. The only difference is you've added height, because even in work equals force times distance, we always have to times the mass by gravity. Okay, and so why would kinetic energy work there? Well, what you'll tend to find is kinetic energy turns into gravitational energy, and gravitational energy turns into kinetic energy. So let me explain that a bit better. You have a ball there. It has 0 kinetic energy. You throw, 0 gravitational energy. You throw it up high. It reaches there. and then it has gravitation, it has GPE up here, okay? Well, the KE, kinetic energy you added to get the GPE up here, they must equal each other, okay? So, in a nutshell, very difficult question to understand, but we're going to take kinetic energy as the same thing as work. Okay, so I want you to remember that. Just if you don't understand why that's the case at this level, you don't have to. You just have to understand kinetic energy is the same thing as work. So I'm going to rub this out and start it again. Now that we know all that fancy stuff, as I say, it's a lot of information for you, and it is really 11 stuff. So write out the equation. Work equals force times distance. It's asking you to calculate the force, so we're going to have to rearrange. Well, that's now easy. We know how to do that now. But on the right side, we're going to do the same to the left side. So we're going to multiply through. And that's our rearrangement. W divided by D equals F. Okay. So now we've got to sub the numbers in. So you're just going to have to take it from me. The clue's in the thing that it's the unit is joules. It's going to be 3 times 6 times 10 to the power of 5 divided by 95. Is it in the right unit? Yes, it is. Meters is the right unit. Equals F. Okay. And so if we stick that into a calculator, we will get the answer, which I believe is 3789. And the unit of force is always newtons. So that was a very difficult question. The next one isn't so bad in my opinion, because it's similar to the ones we've already done. So let's take you through it one more time. EK, now remember the equation, equals 0.5 mv squared. It's asking you the mass of the vehicle. Okay, so we need to make mass the subject. So let's cancel down 0.5 and v squared. Turn that to the right side, 0.5 v squared. Those go equals m. Okay, so let's just actually rub those bits out. That is our equation. EK, sorry, that's a bit scruffy. Let me smarten that up. EK times v squared equals m. Okay, now we've just got to sub the numbers in. EK again, 3.6 times 10 to the 5 divided by 0.5 times velocity, I told you there, 30 squared, okay, equals m. So going down here, always start with 30 squared. Well, I know that in my head, actually, that's 900, 30 times 30, times 0.5. Well, I know that in my head as well, too, but don't do it in your head. Use a calculator. It's going to be 450. Okay, but always do that bit first. Use the memory button on your calculator. It's got a bit of a long nose, that 3. Okay. Divide 3.6 times 10 to the power of 5 by 450. And when we do that, we get 800 kilograms is the answer.